Hi there, this is Courtney and Emmy, and this is our homework for Engineering 460. So for this problem, we are supposed to prove that pi is 3.14 using Monte Carlo, and then give a confidence interval for that.
All right, so the way that Monte Carlo works in MATLAB is you start off by, in this code, is you can set a number of iterations, which are n, and we set it to 100,000. We set our center of our circle and our radius of our circle, and this is where we randomly generate x variables, right here, 100,000 x variables according to n, and randomly generate y variables, 100,000 according to n right here. And what that does is that gives us a coordinates of x and y coordinates. And then before we go into the actual for loops, we want to initialize our I variable, which we're going to use in our for loop, our count R and our count B as well. So then generally speaking, what we're looking at is if the points fall, so this for loop says that if the points fall within our radius that we set, as you can see B is set at 2, then we can go ahead and count it as a point that falls inside the circle. Otherwise, it will fall outside the circle. And what Monte Carlo does is it uses that count of points that fall inside and outside a circle to generate a proportion here. So this is a proportion of what we would consider, and we've heard of, sand that falls inside the circle over total sand that falls outside the circle.
And then this is the code where we calculate our 95% confidence interval. So we find mu by finding the mean of our calculated pi, and we do standard deviation the same way. And then we plug those two values into our confidence interval for upper and lower equations. As you can see here, the 1.96 is a number pulled from stats to find that 95% confidence interval. And then we go ahead and plot it after that. So as you can see in our results, we have pi equaling 3.1415. Our mean we get is 3.1421. Our upper boundary is 3.1431, and our lower boundary is 3.14110, and then this is our figure for it.